Humans have visited the moon. Right now, there are people orbiting Earth aboard a space station, and billions of dollars are spent just to leave our planet. But one country decided to take a completely different path. China has set its sights not on the stars, but deep within the Earth itself. The question is, why? Is this a real scientific mission that could change our understanding of our planet? Or is it a search for new, precious resources hidden beneath the surface? In the Sichuan Basin, some of China's best engineers are currently drilling a hole over 30,000 feet deep, which is about 9,000 meters. That's deeper than any ocean and even taller than Mount Everest. In northwest China, another project is already underway, aiming to reach 36,000 feet or roughly 11,000 meters, making it one of the deepest holes ever attempted. China's mission has two main goals. The first is scientific exploration. Imagine the Earth's crust as a historical timeline, where every layer tells a story about our planet's formation. By drilling into these layers, scientists can uncover Earth's history layer by layer. The second goal is commercial. Deep within these layers, there may be untapped energy reserves. Accessing them could provide China with a vital resource to fuel its development and growth. This ambitious project was initiated in 2021 by President Xi Jinping, emphasizing its importance to the country's leading scientists. The ultimate aim is to reach material that formed over 145 million years ago, providing crucial data for geoscience research. Studying these deep layers can also help assess environmental risks, such as earthquakes and volcanic eruptions, giving scientists insight into hazards that could impact millions. While the drilling may not surpass the record depth of the Russian Kola super deep borehole, which reached 12,300 meters, China's project is a monumental technical feat, planned to be completed in just over a year. The Kola borehole took more than 2 decades to reach its record depth, facing numerous mechanical failures and extreme temperatures along the way. Despite these challenges, the Kola borehole revealed surprises like microscopic plankton fossils at unexpected depths in water where none was anticipated, as well as metamorphic rock beneath granite, offering important proof for plate tectonics. By examining the Earth's crust at such depths, China's project could challenge long-held assumptions and uncover secrets of our planet's mantle. However, reaching these layers won't trigger volcanic eruptions. The rocks move, but extremely slowly, almost imperceptible over human timescales. The mantle, which makes up about 68% of Earth's mass and 85% of its volume, is solid rock that flows gradually under high pressure and temperature, much like a slow-moving lava lamp. Direct access to these deep layers would be equivalent to landing on the moon in terms of scientific significance. It could provide untouched samples of the mantle, offering clues about Earth's formation, density, heat conduction, and seismic properties. Unlike existing mantle samples, which have been altered by volcanic activity or exposed to seawater, this project aims to obtain pristine material, allowing scientists to unlock Earth's deepest secrets for the first time. Throughout history, drilling to such depths has been extremely difficult. Previous attempts, from the United States Project Mohole to the Soviet Kola borehole and Germany's deep drilling programs, faced countless engineering challenges, from high temperatures to equipment failures. Political and financial hurdles often halted progress. Yet, these projects advanced our understanding of the Earth and provided technologies now used in the oil and gas industry. Today, China takes up the challenge with unprecedented resources and an ambitious timeline. With these 2 super deep boreholes, the world will watch closely to see if they can break new records, reach deeper than ever before, and uncover what lies beneath our feet. While some of this effort may have political motivations, the primary goal is scientific: to explore the unknown, understand the Earth at new depths, and expand our collective knowledge about the planet we call home. To understand the difficulty of drilling so deep, it helps to look back at the Kola super deep borehole, the deepest hole ever drilled by humans. Work on this project began in May 1970 and continued until 1994. The scientists faced constant challenges, including mechanical failures and extreme heat that reached 356 degrees Fahrenheit, 180 degrees Celsius, which damaged drill bits and machinery. Yet, despite these obstacles, the borehole revealed surprises that reshaped our understanding of Earth's crust. At nearly 19,700 meters below the surface, They discovered microscopic plankton fossils and water seeping from unexpected depths. Instead of finding basalt beneath the granite as expected, they encountered metamorphic rock altered by heat and pressure, confirming crucial aspects of plate tectonics theory. These discoveries illustrate just how valuable deep drilling can be for understanding our planet. Even though the Kola borehole reached impressive depths, it barely scratched the surface of the Earth. Reaching the mantle would be an entirely different challenge. But if scientists managed to access it, long-held assumptions about Earth's structure could be transformed. The mantle's rocks move incredibly slowly. On geological timescales, they flow like a lava lamp, with heated material rising and cooling as it circulates over billions of years. The mantle is enormous. It accounts for 68% of Earth's mass and 85% of its volume. Unlike molten lava, it is solid rock that flows gradually under extreme heat and pressure. Studying this layer could reveal the raw materials from which the planet formed and provide insight into its evolution into the complex world we inhabit today. Scientists have already gathered mantle samples without drilling that deep. Volcanic eruptions, tectonic collisions, and mid-ocean ridges have brought fragments to the surface. However, these samples have been altered by exposure to air and seawater, meaning they no longer represent the pristine mantle. Obtaining untouched samples would be a groundbreaking achievement, revealing information about density, heat conduction, and seismic properties that could validate or challenge current assumptions about Earth's interior. Throughout history, attempts to drill deeper into the planet have been limited by technical, financial, and political constraints. During the Cold War, the quest to drill as deep as possible mirrored the space race. The United States initiated Project Moho, targeting the boundary between Earth's crust and mantle. They attempted to drill through the thinner oceanic crust near Guadalupe Island, but the technology didn't exist to stabilize the drill ship. Engineers had to invent solutions from scratch, like adding propellers to keep the vessel steady. The Soviets took on the challenge in Russia, while Germany drilled beneath Bavaria, reaching nearly 30,000 feet. All face high temperatures, equipment failures, and escalating costs. In many cases, political and financial issues caused projects to be halted, despite their scientific promise. Even so, these ambitious efforts advanced technology, improved our understanding of plate tectonics, and set the stage for future deep drilling projects. Today, China enters this lineage with 2 super deep holes, substantial funding, and a timeline of just over a year. These boreholes are designed to test the limits of engineering and knowledge, pushing into parts of the Earth that have never been explored. The potential rewards are enormous. Not just scientific discoveries, but possibly untapped energy sources buried deep within the crust. Supercritical geothermal energy, for example, lies up to 20 kilometers beneath the surface. It is a natural battery as powerful as fossil fuels, but clean, sustainable, and with minimal land impact. Accessing this energy could reduce greenhouse gas emissions, provide electricity to billions, and create millions of jobs, all while preserving forests and wildlife. As China drills, the world watches. Every layer uncovered adds to our collective understanding, pushing the boundaries of human knowledge. Drilling deep is more than digging holes. It is about curiosity, discovery, and the relentless pursuit of the unknown. With each meter drilled, China moves closer to understanding the Earth as never before, revealing secrets hidden for billions of years beneath our feet. Beyond the technical challenges, China's deep drilling effort represents a broader ambition to understand our planet at unprecedented depths. Each layer they penetrate tells a story, revealing the history of Earth's formation, shifts in tectonic plates, and even clues about past climate conditions. These findings could provide valuable information for predicting earthquakes, volcanic eruptions, and other natural hazards, helping protect millions of people. While drilling may seem like a purely scientific pursuit, it is also a test of human ingenuity and endurance. Engineers must contend with extreme temperatures, intense pressure, and the constant threat of equipment failure. Drills must be precise to avoid deviation, while machines operate under conditions that would destroy ordinary equipment. The margin for error is almost non-existent. China's ambitious plan draws lessons from the past. The Soviet Kola borehole took over 20 years to reach 12,300 meters, and even then, drilling was halted by heat and mechanical breakdowns. Germany and the United States face similar issues, with costs spiraling and projects eventually abandoned. China, however, combines advanced technology with substantial resources, aiming to achieve what previous nations could not in a fraction of the time. The deeper they go, the more we may uncover about Earth's inner workings. Scientists hope to understand how heat and material move through the mantle, influencing surface phenomena like earthquakes and volcanic activity. By studying these movements, researchers can improve models of Earth's dynamics, potentially predicting catastrophic events more accurately and safeguarding communities. The mantle itself remains largely a mystery. Its rocks flow slowly under extreme pressures and temperatures, shaping the planet's geology over millions of years. Accessing samples from this layer could reveal the original materials from which Earth formed, providing a glimpse into processes that occurred billions of years ago. This is akin to holding a key to the planet's most guarded secrets, a direct connection to the Earth's origins. China's drilling also has the potential to discover energy sources that could transform the global energy landscape. Supercritical geothermal energy, buried deep within the crust, could provide abundant, clean power. Unlike solar, wind, or hydro, this energy source exists beneath the Earth, largely unaffected by weather or seasonal variations. Successfully tapping into it could alleviate energy poverty, reduce dependence on fossil fuels, and help combat climate change on a massive scale. Each meter drilled is both a scientific achievement and a step toward potential breakthroughs in sustainable energy. While political motivations may be present, the overarching goal remains clear: to explore the unknown, advance human knowledge, and push the boundaries of engineering and geoscience. The world will watch as China continues this unprecedented journey, combining curiosity, technical skill, and bold ambition. Every layer uncovered, every sample extracted, brings us closer to understanding our planet in ways never before possible. It is a story of exploration, discovery, and the relentless pursuit of knowledge, pushing humanity toward the depth of the Earth, just as space exploration reaches for the stars. As the drilling progresses, scientists pay close attention to the geological changes they encounter. Every rock layer tells a story, not only about the Earth's past, but also about its present and future. Minerals, chemical compositions, and fossil evidence provide clues about plate movements, volcanic activity, and climate changes that occurred millions of years ago. Reaching these depths is not just about science. It is a challenge of human engineering. Equipment must withstand crushing pressure and extreme heat, while maintaining precision over thousands of meters. A single miscalculation can halt progress or even destroy expensive machinery. This delicate balance between exploration and risk defines the entire mission. China's project also builds on decades of global knowledge. The lessons learned from the Kola Super Deep Borehole, German deep drilling, and Project Moho show that deep drilling is never straightforward. Mechanical failures, temperature extremes, and unpredicted geological surprises have always posed significant obstacles. Yet, each attempt has advanced technology, refining drilling techniques, and creating new possibilities for scientific discovery. One of the most intriguing aspects of this mission is the potential for energy discoveries. Beneath the Earth's crust, supercritical geothermal energy may provide a virtually unlimited clean energy source. Unlike wind, solar, or hydro, this energy is independent of surface conditions and can power entire regions sustainably. Accessing it would require overcoming extreme engineering challenges, but the potential rewards are enormous: reduced greenhouse gas emissions, new energy infrastructure, and jobs for millions. Beyond energy, drilling deep into the Earth can improve our understanding of natural hazards. By studying ancient rock formations and current movements, scientists can gain insight into earthquakes, volcanic eruptions, and landslides. These insights may allow for better predictions, providing communities with early warnings and potentially saving countless lives. Every drill meter taken is a step closer to understanding the mantle, the vast layer beneath the crust. This layer, which makes up the majority of Earth's mass and volume, flows slowly but powerfully, shaping the planet's geology over millions of years. Accessing samples could reveal the original composition of the Earth, offering clues about how our planet formed and evolved over billions of years. China's deep drilling mission represents both ambition and curiosity, a bold attempt to answer questions that have fascinated humanity for centuries. With state-of-the-art technology, substantial funding, and an aggressive timeline, this project could finally unlock mysteries that previous generations of scientists could only dream of exploring. In essence, this mission is more than drilling. It is about exploration, understanding, and innovation. It is about pushing human knowledge to its limits and uncovering secrets hidden for billions of years beneath our feet. Every discovery, whether a rock sample, fossil, or new geological insight, brings us closer to comprehending the inner workings of the planet we call home. As the drills penetrate deeper, scientists begin to analyze each layer for clues about Earth's dynamic processes. Minerals, fossils, and chemical compositions reveal the history of plate tectonics, volcanic activity, and ancient climates. This data not only informs geology, but also provides context for environmental risks that could affect millions of people. The engineering required to reach such depths is staggering. Extreme pressure and temperature challenge every piece of machinery, and precision must be maintained over thousands of meters. Any small error could halt drilling or destroy the equipment entirely. The mission is a careful balance of risk and progress, with every meter representing both technical achievement and scientific potential. China's project is unique because of its combination of resources, advanced technology, and ambitious timeline. Previous attempts, like the Soviet Kola borehole and German deep drilling projects, faced delays, mechanical failures, and funding issues. Despite these challenges, each effort advanced the science and technology required for deep drilling, paving the way for China's success. The potential rewards are enormous. Accessing supercritical geothermal energy beneath the Earth's crust could provide a sustainable, clean, and virtually unlimited power source. Unlike solar, wind, or hydro, this energy is independent of surface conditions, offering reliable energy with minimal environmental impact. If successfully tapped, it could reduce dependence on fossil fuels, create millions of jobs, and help combat climate change. Drilling deep also advances our understanding of natural hazards. By studying ancient rock formations, scientists can learn more about earthquakes, volcanic eruptions, and landslides. Improved knowledge of these processes can lead to better predictions and early warnings, helping to protect communities worldwide. The mantle, lying beneath the crust, remains largely unexplored. It accounts for about 68% of Earth's mass and 85% of its volume. Its rocks, though solid, flow slowly under extreme heat and pressure. Accessing pristine mantle samples could reveal the Earth's original composition, shedding light on how the planet formed and evolved over billions of years. China's deep drilling mission is a testament to human curiosity and engineering skill. It combines bold ambition, advanced technology, and scientific insight to explore regions of Earth that were previously unreachable. Every meter drilled brings new knowledge, pushing the boundaries of what humanity can understand about our planet. In essence, this project is more than just drilling. It is a journey of discovery, a pursuit of knowledge, and a demonstration of the incredible potential of human ingenuity. Every sample, every layer studied, helps scientists uncover the secrets of the Earth's interior, inching closer to answering questions that have fascinated generations.